everyone, welcome to this session on AI data models. So, in this video, we are going to explore one of the most fundamental aspects of artificial intelligence. So, we are going to see how AI system model problems and data in order to find solutions. So, before an AI system can think, reason, or make decision, first it needs to understand the problem. So, and that understanding comes from data models or modeling. So, today we will look at different types of models used in AI, from early logic based models to modern statistical and semiotic models. So, when we complete this session, you'll have a clear understanding of why modeling is important and how models have evolved over time and what types of models power today's intelligent systems. So we will go through one by one and let's understand. So first we will talk about the importance of modeling. So why modeling is important? So the answer is simple. Building any AI solution starts with modeling the problem correctly. Very, very important. If you don't model the problem well, so no matter how powerful algorithm you are using, the solution will fail. So to understand this better, let's look at the early contributions from psychology. So there was a researcher named Dunker who introduced the concept of trace hypothesis in psychological problem solving theory. So for that we should understand what is trace hypothesis. Dunker said that creative and intelligent human tasks can be modeled like a set of mass options. So what is the meaning? When a person is solving a problem, there are essentially they are essentially looking at a large number of choices available to them. Yes, na? So when we wanted to have a food, we will try to find all possible options, right? So a person who spends time analyzing many choices is more likely to identify the one that leads to the goal. So this is a very important aspect we have to understand. So this is exactly what AI systems try and do: explore options and find the best solution or the best available path. And importantly, the choices and the mental attachments formed during this analysis helps to find effective solutions. So in AI term, this is very similar to how search algorithm works, exploring the paths, eliminating the dead ends, and finding the optimal route to the solution. So, the foundation of AI modeling is rooted in how humans naturally think and solve problems. Next, we will talk about the limitations. Okay. So, as AI research progressed, it became clear that not all problems can be solved using major models or approaches alone. So, what next? Early AI researchers tried to apply one or two dominant models to all kinds of problems. So, but they quickly realized that a model that worked well for one type of problem may completely fail for another. That's true. So, this was a major turning point in AI research. So, this limitation led to increased focus on something called as logic theory missions. Okay. Now, I will talk about what is or understand the role of logic theory missions. So, what logic theory missions did or what are they and why are they, why, how did they become so important? So, that we should understand. Okay. So, for that, just a minute. So, for that, okay, now we will talk about this role of, the logic theory one by one. Okay. So, Logic theory machines were found to be very useful in general problem solving. So, unlike earlier rigid models, they could handle wide variety of problems. They also provided high effective for knowledge representation. Okay, so which is a process of storing and organizing information so that a machine can use it to reason and make decisions. Okay, so most importantly, this logic theory machines helped bridging the gap between the human reasoning and machine processing. So this was a significant achievement because human reasoning is flexible, contextual, and something ambiguous. And getting machines to replicate was a major challenge. Okay, so this tells us how AI evolved. Okay, researchers kept discovering the limitations of existing models and kept building better ones. So now we will discuss about the next topic, that is a model complexity framework. So we'll talk about the complexity framework. So this framework helps us understand the relation between model complexity and AI building. Okay, you can see here. So this framework is mapped across two axes. You can see this diagram for that axis. So the x-axis represents the complexity, okay, and the y-axis represent the model type. This is a y-axis. So this is the x-axis and this is the y-axis. Okay, so it represents the complexity and the model. Now, x-axis tells us how complex the problem or the model is, and the y-axis tells us what kind of model is being used. So as we move along these axes, what we are understanding, we can see that how the nature of AI models changes with increasing complexity. Okay, we can see that how the complexity is being increased. Okay, so this framework gives us a structured way to think about AI model. Okay, not just as an isolated tools. So next, we will talk about the framework of the model complexity. So there are three key processes here. The first one is discover process. So this is the starting point. At this stage, we are identifying patterns. You can see here we are identifying patterns and relationships in data. So this is why, or this is what the data mining and knowledge discovery do. They look at raw data, find hidden patterns that are not immediately obvious. Secondly, we will talk about knowledge based modeling or knowledge based model building. That's the second key process. So, once patterns are discovered, we use domain expertise to define rules. So, in the first process, we identify pattern. Second process, we take the help of the expertise. So, this is where human knowledge is enclosed into the system. Experts define what the machine should know and how it should reason. Okay, so this is the basis of expert system. Okay, now third is about the application building, third process. This is the final stage. Now we are here, like this is the final stage. Sorry, this is the final stage. So, where models are translated into deployable applications. So, this is where everything comes together. The patterns, the rules, the algorithms are packed into a working AI system. So, what do we try to do in this key process? We try to discover, then we first try to discover, then we try to use expertise, then we put everything together. Okay. So what we understand from this, that as the complexity increases, the approaches shift from a simple knowledge based model to a full AI application development. This is what we said. Okay. Full application development. So, directly you cannot jump into building an AI application. So, you have to go through all these stages. And importantly, mapping between these stages is critical. Okay. So, we know there are stages. So, mapping is going to be again a very critical task. So, if you wanted an effective AI system, then this mapping should be done with care. So each stage feeds something to the next stage. Now, what we will do is we will take an example. Okay, the classic example is the chess. Here, chess is considered as a classic and much complex scenario. Okay, so that motivated AI research enormously. Let's talk about why. Chess provided an excellent test bed for AI researchers because there are several reasons. First, it is a well defined problem with clear rules and goals. So there are fixed rules about how each move should happen. We know what is the goal, when the checkmate will happen. So this made it easy to do the model. Second, it requires look ahead planning and decision making. So a good chess player doesn't judge doesn't just think about the next move. They think about several moves ahead. So this is a kind of strategic thinking that AI researchers wanted to replicate in the machines. So studying this chess program gave two important aspects or two ideas to the researchers. First one is search and knowledge representation. So, chess programs required efficient search algorithms to explore all possible moves and knowledge representation techniques to evaluate the positions in the board. So, this became the foundational concept of AI. Second, model building for AI applications. Okay, so what happened here? We know chess is a framework. So, to make the complex decisions, you need some proper framework. So, to take some decisions. So, here it is very important that we have to understand that the models developed for chess program were not effective for other general applications. Every application is different. So, a model that plays a chess brilliantly cannot be useful for medical diagnosis or a financial application. So, this was the highlight how the AI is going to be distinguished. So, the difference between domain specific models and general purpose models. Again, this became a very challenge for the researchers. Okay. Next, we will talk about artificial intelligence and building intelligent systems. As AI grew and developed, the advancement highlighted a very important need: effective man machine dialogue. So that became very important. Effective man machine dialogue. So what does it mean? It means that for an AI system to be truly useful, humans and machines need to communicate and work together effectively. So the machine needs to understand human inputs and respond it in a meaningful way. That's true. So as researchers worked, it became more and more evident that existing models had their own limitations. Okay. So we will understand that formal models that were proposed to solve the AI problems were not sufficient for complex scenarios. Okay, so now we will understand the limitations. Formal models worked well, how it worked for simple problems and structured problems. Wherever there were rules that were clear, data was clean, the solution was predictable. So solving a very simple mathematical equation was very easy. So when it failed, when they were not able to handle the requirements of complex problem solving, when complex problem solving comes, when it is dealt with the real world problems, where a lot of uncertainty, messy and context dependent things happen. A formal model that works perfectly in a controlled environment often breaks down when exposed to real world complexity. Now, this gap between the formal models could do and what real AI systems needed to do. So, this was the called for the development of newer and more flexible approaches. Now, let us discuss about rise of inductive dynamic models. Okay, so the need for complex problem solving led to the popularity of ability based inductive dynamic models, right? So what did they do? These models were specifically designed for creative problem solving. Okay, so the kind of problem solving that formal models could not handle. So they became the preferred approaches, these models. Okay, they became the preferred approaches in situation where traditional models did not pass. So now we will understand what is the difference between the static models and adaptive models. So older models were statistic and rule based. They were fixed and rigid in nature. Once programs, they cannot be changed. So if the environment changed or new data comes into, then the model cannot adapt to it. Okay, it would still follow the same fixed rule. So that is very bad. Like we cannot adapt the dynamic environment because dynamic environment has lot of uncertainties. Newer inductive dynamic models are adaptive and learning based. So this is the fundamental shift in AI. So these models can evolve and improve based on the experience and new data. Every time the model encounters a new situation, it learns from that and it updates itself. So this is the concept of machine learning. Okay. So this model, the idea that a model should get better over time was evolved. So next, it's like a recipe book. Like if you're trying to say recipe book is static, so it will give you instructions like, but the environment is dynamic. You have to adapt to it. You have to change according to the feedback given. Okay, right. Next, we will discuss about semiotic models in AI. So semiotic models are based on science, processes of signification, and communication. The word semiotic means or comes from the study of signs and symbols and how meaning is created and communicated. So now let us look at the characteristics one by one. First one is the process of communication depends on codes. So semioticians or people who study semiotics classify signs or sign system in relation to the problem being solved. So every language, every symbol system, every form of communication follows a set of codes. The meaning, assignment and mapping process depends on the use of codes which are based on rules. So when you read a word, you are using a code, the rule of language. So this gives meaning to the letters. These codes are sign systems that humans use to form words or to communicate with the computers. When you type a command, for example, in the computer, you are using sign system that computer understands. Signs are determined for logical sequence. In semiotic models, signs are organized in a structured, logical way so that the system can process them meaningfully. So, why are semiotic models important in AI? So, it helps in building systems that understand and process symbolic human language and communication. So, this is directly related to NLP, that is natural language processing. How AI system understand human language, interpret meaning and response appropriately. Okay, like you use a chatbot, you use a voice assistant. So, all these how are examples of semiotic models work. Next, we will discuss about statistical models in AI. Statistical model refers to the representation and formulation of relationship through statistical techniques. Okay, so they are very useful for solving AI based mathematical and pattern matching problems. So means they use mathematics and probability to find patterns in data. Okay, so the key points here are various learning models from from an AI perspective are based on statistic. So most of what we call as machine learning today is built on statistical function. The statistical description of a process as a system follows probabilistic and statistical approaches. So instead of saying this will definitely happen, statistical models say that there is an 80% of probability that this will happen. So this is much more realistic in the real world situation. So a statistical model is typically a collection of probability density function and distribution function. So these are generally the mathematical tools that describe how data is distributed and how likely different outcomes are. Okay, so the applications include classification, regression, clustering, anomaly detection, and probabilistic inference. So, what is classification? Deciding which category something belongs to. Is this email a spam or not? What is regression? Predicting a numeric value. What will be the price of this particular house or a toy? Clustering. Grouping similar item together. Segmenting the customers together based on their behavior. Anomaly detection. Identifying unusual patterns like fraud detections. Probabilistic inference, we are trying to draw some conclusions from incomplete data. Now, we will talk about the comparisons of all these models. So, we have covered logic theory machines, formal models, and then we have talked about inductive dynamic models. Okay, and then semiotic models, statistical models. Okay, so logic theory machines, it is useful for general problem solving and knowledge representation. It is structured, it is rule based, and it works well. So for formal models work well for simple and structured problems, but for complex problems it fails. Okay. If we talk about the inductive dynamic models, they are adaptive and they learn from the experience. When we talk about the semiotic models, they are based on science and communications. So it's essential for understanding symbolic reasoning. Applications are NLP and language understanding. Talk about statistical model. So it's probabilistic. It's used for pattern matching and classification. Now, each type of model has its own strength and weakness. So no single model is perfect for all problems. So the choice of model generally depends on the nature of the problem, the type of data available, the complexity of the task, and the domain of the application. So that is why the new models are being evolved. They try to combine the existing ones, build a new powerful versatile system. Now, finally, we will summarize whatever we have seen so far. So, AI solution building begins with proper problem modeling. So, before we write even a single piece of code, you must model the problem correctly. That's a foundation. Point number two, not all models will work for all problems. So, domain specificity matters. A model that is used for chess cannot be used for another problem that is used in a real world. Always choose your model based on what kind of problem you are solving. Okay. Next is the chess. Chess served as a landmark complex scenario that shaped AI research. So it gave us the concept of search, knowledge representation, and model building. Point number four. What is point number four here? Models evolved from rule based, knowledge based, statistical, or dynamic, and inductive. So, this evolution reflects the growing complexity of the problems that the AI is expected to solve. Then we talked about semiotic and statistical model. Okay, so semiotic models deal with the science, well, statistical model deals with the probabilistic data or inferences. So, finally, what is the goal of AI? Is to give computers a situation and a goal and let them find a solution. So, this is the ultimate aim. So, building systems that can reason, that can learn and solve problems on their own. So, the references are from Stuart Russell and Peter Norvig and Parag Kulkarni. Thank you.